Welcome to this presentation. I'm Daniel and the title of our paper is Exploration Strategies for Articulatory Synthesis of Complex Syllable Onsets. This work was done as part of a project on simulating early vocal learning funded by the Leverhulme Trust. The premise of this investigation is of a practical nature. High-quality articulatory synthesis is promising for speech science and technology due to its flexibility and interpretability compared to traditional speech synthesis. However, defining meaningful articulatory gestures is a bottleneck. In practice, articulatory synthesizers come with predefined articulatory gestures defined by the developer. For example, the articulatory targets on the right are required to produce the CV syllable ga. This requires a significant amount of phonetic expertise as well as knowledge of the actual system. The process is time-consuming, and the nature of the synthesized speech reflects the decisions made by the developer. Ideally, this should be evaluated externally using listening experiments to quantify naturalness and intelligibility. Lastly, these articulatory gestures are not completely independent of language or dialect and need to be redefined in the event that an additional speaker model is developed. For these reasons, we are interested in a process to self-learn a set of meaningful gestures to produce syllables given a target language and speaker. This resembles the conditions faced by infants during vocal learning, of which the following important facts are known. The process of vocal learning progresses through various stages of babbling, eventually leading to the production of meaningful syllables. Secondly, auditory perception develops earlier and becomes increasingly language-specific during this process. Vocal learning has to contend with two major conceptual problems. Firstly, the issue of speaker normalization, where the question is how a learner with an immature vocal tract can begin to compare its speech with mature speakers, and secondly, the correspondence problem, where the learner has to establish the correspondence between its articulations and utterances and the surrounding semantic context. Studies of deaf learners have shown that auditory feedback is critical to successful vocal learning. It has also been shown that somatosensory and visual feedback is useful during the process. And lastly, in computational studies, the later stages of articulatory exploration is usually considered to be goal-oriented or driven by a specific objective. Our approach is to implement goal-directed articulatory exploration as an optimization task as follows. Firstly, we define a language-specific auditory perceptual space by training a syllable encoder on a speech recognition corpus. This corpus provides us with examples of grounded speech and also a set of goal syllables relevant to the language. The syllable encoder, in turn, can be used to define a language-specific auditory objective for the exploration process. Secondly, we make use of the tube area functions provided by the speech synthesizer to define a set of speaker-specific or somatosensory targets that need to be satisfied during the optimization process. The overall process of articulatory exploration is driven by a generic objective function which chooses which parts of the articulatory space to sample and to generate samples that are compared against both the auditory and articulatory objectives. For each instance of this process, a specific syllable is chosen as an objective and encoded in terms of its auditory and perceptual goal vectors. Finally, the outputs are sets of articulatory targets that can be used to produce syllable gestures using the target approximation model. In previous work, we performed listening tests to confirm the intelligibility of CV syllables derived using this framework. We also analyzed the plausibility of articulatory gestures by including different regularizing articulatory objectives. In this paper, we extend that work to complex syllable onsets with the following specific questions. Firstly, it's possible to explore the articulatory space in separate stages to find appropriate targets for the vowels and consonants. Secondly, we explore the inclusion of articulatory distance between the vowel and consonants to account for co-articulation observed in natural speech. And lastly, we wish to observe whether there are any specific syllable types which are more difficult to discover in this framework. In our current experiments, we use the Vocal Tract Lab synthesizer to find gestures for American English syllables. We focused on the upper vocal tract parameters and used appropriate presets for the glottis model. We investigated the set of valid CCV syllables in American English, excluding nasals and diphthongs. We trained the syllable recognizer to recognize any CCV syllable in American English based on the LibriSpeech corpus. We included basic articulatory objectives that represent somatosensory feedback that detects whether the vocal tract is closed for the consonant and open during the vowel. We tested the articulatory distance objective motivated by co-articulation. And we implemented different exploration strategies ranging from joint optimization to sequential, starting with the vowel followed by the consonants. Since we're interested in the relative performance of different system configurations, we started by comparing the exploration strategies in terms of the success rates achieved against the auditory objective. While this does not allow us to assert the naturalness or quantify the intelligibility of the resulting samples, it does provide a means to compare the relative difficulty of the different exploration strategies. To confirm this, we inspected the utterances manually, and the samples can be accessed through the link provided in the paper. The following table provides a comparison of 4 different exploration strategies. The first column, joint optimization of all parameters. The second column, optimization of the vowel parameters followed by joint optimization of the syllable onset. The third column, sequential optimization starting with the vowel followed by the initial consonant and then the intermediate consonant. And the last column, sequential optimization starting with the vowel followed by the intermediate consonant and then the initial consonant. 3 findings are derived from statistically significant differences in the results. Firstly, optimization of the vowel followed by joint optimization of the syllable onset resulted in the highest success rate on the syllable level. Secondly, optimizing the intermediate consonant before the initial was significantly less successful. And lastly, when applying the articulatory distance for co-articulation, the vowel should be optimized independently of the onset. We also investigated the normalized articulatory distance between the initial consonant and the vowel when optimizing with and without the co-articulation objective. While there was no significant difference in the auditory success rate, the plots here show that the inclusion of the co-articulation objective effectively reduces the articulatory distance between the consonant and vowel. This procedure can be used to investigate the independence of different articulators in different phonological contexts. For example, for the bilabial consonants, it is clear that the lip distance has to vary significantly between the consonant and the vowel. However, the tongue tip can have a significantly smaller distance. In summary, we find that joint optimization of the onset is most successful, and if performing sequential optimization, the initial consonant should be optimized before the intermediate. We show that the articulatory distance can be used as a regularization objective to discover contextual articulatory coordination if the vowel is optimized first. This paper and our previous work shows how auditory and articulatory feedback mechanisms can be combined in a general optimization framework to discover intelligible CV and CCV syllables. Future work should extend this investigation to cover the full set of English syllables. The results should be evaluated using formal listening experiments to quantify intelligibility and naturalness, and the data generated during exploration may be used to train forward and inverse models to further improve the precision of articulatory gestures. Thank you for listening to this presentation, and we invite you to inspect some of the samples linked in the paper and attend our show and tell during the conference.